Assalamu alaikum. Welcome to my class. This is Muhammad Rafiqul Islam. Dear learners, how are you? I think you all are well. Dear learners, today I will discuss geometry. That is, I will discuss about circle, tangent, and secant of a circle. First, I am drawing three figures. Here, circle and have one straight line. This is figure number 1. Here, figure number 2. Is the figure number 3. What are you seeing? In figure 1, the straight line and circle have in a plane, but they do not intersect each other. That is, there is no common point of the straight line and circle. Here, the straight line intersect the circle at 2 points. The straight line in figure 3 intersect the circle 1 point. If the straight line intersect the circle at 2 points, the straight line is called secant. That is, it may be chord or radius to the circle. Here, this is the secant. Its name secant. Here, this is the secant to the circle. Here, figure 3, the straight line intersect the circle at 1 point. So, the straight line is tangent to the circle. Here, this is the tangent this circle. In figure 3, here the straight line, suppose I am mentioning this straight line ABC with the center. ABC is the tangent of the circle. If two straight lines have one tangent, this is the common tangent. I am drawing some figures. Okay, here the tangent. This is the same here. Okay, dear learners, suppose this is the figure number 1, this is the 2, 3 and 4. We are seeing here the straight line, the circle, these two circles have one tangent. This is the common tangent of this circle. Both figure we are seeing. First figure, the center of this circle lies same side on the of the tangent. So this kinds of tangent is called direct common tangent. Similarly, if two centers lie same side of the tangent is called direct tangent. Here the center, these two centers lie same side of the tangent, this tangent. Also here two center lie of the same side on the same side of the tangent. So here these tangents are direct common tangent. Here figure 1 and 2, these tangents are direct common tangent. Direct common tangent. If two center lie opposite to the tangent is called transverse common tangent. Here these two centers lie opposite to the tangent, so these tangents and also these tangents is transverse common tangent. Transverse common tangent. Okay, now I will prove theorem. First I am writing 1. Here theorem 25. This kinds of theorem is related to tangent. Theorem 25. First I am writing the tangent drawn at any point of a circle is perpendicular to the radius through the point of contact. Through the point of contact of the tangent. Again I am reading the tangent drawn at any point of a circle is perpendicular to the radius through the point of contact of the tangent. Suppose here this is the circle and PT be the tangent of the circle with center O, and P is the point of contact. OP be the radius through the point of contact. It is required to prove that OP is perpendicular to PT. Let this is the this is the particular enunciation. Let PT be the tangent of a circle with center O OP be the radius through the point of contact P. It is required to prove that OP is perpendicular to PT. Drawing is needed here. Take QB any point on the tangent and join OQ. Take Q be any point on the tangent PT and join OQ. Proof. Since PT since PT be the tangent of this circle and P is the point of contact of this circle, all the points on the tangent except P outside the circle. Therefore, Q will be the outside of this circle. Here the distance from center to Q, this will be greater than the distance from O to P. That is, OQ is greater than OP. This is true for all points on PT except P. So here OP is the shortest distance from center O to PT, and we can tell easily OP is perpendicular to PT. Since PT be the tangent of the circle, all points of the circle all points on all points on PT except P outside the circle. Therefore, Q be the point which is outside the circle. So the distance OQ is greater than OP. It is true for all points except P. So OP is the shortest distance from O to PT. So we can tell easily OP is perpendicular to PT. Therefore, OP is perpendicular to PT. We can explain, suppose here is straight line and O is the point. I am drawing some distance from this point on the straight line. Dear learners, we see here OA, OB, OC, OD. The distance from O Here OA, OB, OC and OD. So what will be the distance from center to the straight line? Here OB, this is the shortest distance, that is OB is perpendicular to this straight line. So according to this discussion, we can tell here OP is the shortest distance from center to this PT, that is OP is perpendicular to PT. Now theorem 26. Theorem 26. If two tangents are if two tangents are drawn to a circle from an external point, the distances from that point of to the point of contact, that point to the point of contact are equal. Okay, I am reading this. If two tangents are drawn to a circle from an external point, the distances from that point to the point of contact are equal. Suppose here circle O is the center of its, PB any point outside this circle. I am drawing tangent on it. Here PA and PB, these two tangent, and A and B are 2 points of contact of these two tangent PA and PB respectively. OA and OP are joined. Okay, now particular enunciation. Let PA and PB are two tangents are drawn to a circle with center O, from an external point P. Here A and B are 2 points of contact of these two tangents PA and PB respectively. So the distance from P to A and P to B are equal. It is required to prove that it is required to prove that TA is equal to PB. Drawing, let us join OA, OB and OP. Proof. Since PA be a tangent to the circle and A is its point of contact. Point of contact. OA be the radius through A. So we can write OA is perpendicular to PA. That is here PAO is equal to one right angle. Similarly, a PB another tangent and BB its point of contact and OB be the radius through B. So OB is perpendicular to PB, that is PBO is equal to one right angle. We can write similarly PBO is equal to one right angle. This is one right angle, this one angle. So we can tell easily triangle PAO and triangle PBO, these two are right angle triangle, because we know if one angle of a triangle is one right angle, that is 90 degree, the triangle is right angle triangle. Between two right angled triangle PAO and triangle PBO, here OP be a hypotenuse of these two triangle. Hypotenuse OP is equal to hypotenuse OP, because here OP and OP common side of these two triangle. This is common side. OA is equal to OB. Radius of same circle equal. Radius of same circle. So we know if hypotenuse and one side of two triangles are equal of right angle triangle, so we can tell easily these two right angle triangles are congruent each other. Here triangle PAO is congruent to triangle PBO. That is, PA is equal to PB. The proof is completed. Dear learners, you will practice on these two at your home attentively. Thanks for watching my class.